In this example, we're going to look at permutations of objects by taking a certain number of them at a time. In previous examples, we took all the letters. In this example, we're going to look at the 4 letters A, B, C, and D and look at permutations of them, just taking 2 at a time. So let's just write out some of those permutations. Let's suppose that A is our first letter. Well, we could have chosen B for our first letter, or we could have chosen C, or we could have chosen D. But if we had chosen A for our first letter, how many ways can we choose the second letter? Well, you can see there are 3 letters left, so we could have AB here. We could have AC, or we could have AD. So you can see there are 4 ways to choose the first letter, and we have 3 ways then to choose the second letter, because there are 3 letters left. So if B had been our first letter, we would have either BA, BC, or BD. If C was our first letter, we could have CA, CB, or CD. If D had been first, we would have DA, DB, or DC. So you can see that there are 3 times 4 equals 12 ways of arranging the 4 letters A, B, C, and D by taking 2 at a time. So we have 4 ways to select the first letter. They're the letters in red. And for each of those 4 ways, we have 3 ways of selecting the second letter. So by the fundamental principle of counting, we just multiply these together to get our answer of 12. So if we have 4 letters and we're selecting 2 of them, we start with 4 and we multiply back, but we only multiply so we have just 2 numbers here, 4 by 3. If we were taking 3 of these 4 letters at a time, we would have 4 by 3 by 2 ways. So we'd have 1, 2, 3 numbers here in this multiplication. So 2 numbers appear in the multiplication, 2 numbers 4 and 3, because we are taking 2 of the 4 letters at a time. Now there is a notation for this that you may see on your calculator. 4 times 3 is sometimes written as 4p2. So we have 4 letters, choose 2. So obviously we can extend our method to a more complicated example that's not so easy to write down because there are so many of them. Let's find a number of ways of arranging the letters A, B, C, D, E, and F, taking 3 of them at a time. So how many letters have we here? We have 1, 2, 3, 4, 5, 6. 6 letters. So we have 6 ways to choose the first letter. After we've chosen one of these 6 letters, there are 5 remaining. So we have 5 ways to choose the second letter. After choosing the second letter, there are 4 letters remaining, so we have 4 ways to choose the third letter. So by the fundamental principle of counting, we have 6 times 5 times 4 ways of arranging the 6 letters, taking 3 at a time. So 6 5s are 30, 4 30s are 120. We have 120 ways. And this can be written 6p3. So we start at 6 and we multiply back towards 1, so that we just have 3 numbers appearing here, because we're taking 3 of the 6 objects at a time. So 3 appears here, that's the number we're taking, and 6 is the total number of objects that we are arranging. So some calculators have a button. It may be denoted NPR on your calculator, or it might appear like this. So if you want to do this calculation on your calculator, you'd type 6, then you'd press the NPR button, and then you would press 3, and the answer will be 120. Now let's take a more relevant example. Let's find a number of ways of arranging or permuting the numbers of the lottery, which currently are the numbers 1 to 45, taking 6 at a time. So the current lottery uses the numbers 1 to 45, and 6 numbers are chosen from the numbers 1 to 45. So we have 45 ways of selecting the first number. And after we've selected the first number, there are 44 ways of selecting the second number. And so on. 43 ways for selecting the third number, because there are 43 numbers left after we have selected the first two numbers. So we write down all the different ways for selecting each number. There are 40 ways to select the sixth number, because there are only 40 numbers left after the first 5 numbers have been picked. So by the fundamental principle of counting, we multiply all these ways together. You can do this on your calculator. Use the NPR button, press 45, then the NPR button, then 6. So when you do this calculation, you get 5,864,443,200 ways of permuting the numbers of the lottery, taking 6 at a time. Now, of course, we have a huge amount of repetition here in amongst all these different ways of permuting 6 numbers. For example, one of the 5,864,000,000 ways of permuting the 6 numbers could be the numbers 2, 5, 31, 18, 19, 12. So this could be one of the permutations. But of course another one permutation could be the numbers 12, 31, 5, 18, 2, 19. We would see these as 2 separate permutations. But of course, for the purposes of doing the lottery, these are the same. Same numbers appear in both sets of permutations. So even though we have 2 different permutations, we would say that we have the same combination. In the next few videos we will be discussing combinations. And that's what we're really interested in when we're calculating the number of ways of selecting 6 numbers from 45 in the lottery. The number of combinations will be much smaller, because the combinations are unique permutations. All the combinations are different permutations. Well, all the different combinations have at least a number that's different. That's what I should have said. We count these as 2 different permutations, but all the numbers are the same, so they are the same combination. But we're interested in all the distinct combinations, which is going to be much smaller than this. We need to divide down this number, so we'll cover that in later videos.